Hello, my dear and wonderful students. This is Mrs. Raro, and I am here to show you the triangle midsegment theorem. Okay, so let's start. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half of its length. So for example, say we have triangle ABC, right? And inside this triangle ABC is triangle ADE. All right, so say for example that this point D is the midpoint of AB, that would make BD equivalent to DA, okay? And then say for example that E is the midpoint of AC, then AE would equal EC, all right? That would make DE called the midsegment. It is a segment that joins the midpoints of two ends of two sides of the triangle. All right, so DE here is the midpoint, is the midsegment. Okay. What is true about this midsegment is that it is parallel to the third side, which is BC. Okay, so once you have two parallel lines, then we also have corresponding angles that are congruent. So angle ADE, this angle right here, which I'm going to highlight as yellow, is corresponding with angle ABC and is congruent. Okay. Also, another important fact is that AED is also a corresponding angle to ACB, so these two angles are also congruent. Okay, not only that, the midsegment also states that it is half of its length. So the midsegment DE is half of the length of BC. So say for example, DE was 5. Okay, that would mean that BC is equal to 10 if DE was the midsegment. All right, so again, so DE, if that is the midsegment of the triangle, then BC would be twice of that, all right? Or DE would be half of BC, okay? So those are just several examples here that we have with the midsegment theorem. All right, so let's correlate that with some algebra. All right, so I've placed the theorem here on the left side, and I am asking for the value of x here using this problem on the right side. All right, so we're going to assume that A is the midpoint and B is the midpoint of YZ. That would make AB my midsegment. All right, so again, what midsegment means is that this AB is half of this XC, right? So you can think about it two ways. AB is half of whatever XZ is, all right? Or you can say XZ is equal to twice or 2 times whatever AB is, all right? So I'm going to go with the first one. So it says that AB is half of whatever the length of XZ is. So that makes AB half of 34. Okay, so if you divide 34 divided by 2, you get 1/7. Okay, so that's 17. And so AB has to equal 17. Okay, so because we know that AB has to equal 17, that has to mean that 3x minus 1 is equal to 17. Okay, now it's easy for us to solve for x, because from here we would add 1 to both sides. So we have 3x equals 18, and now x is equal to 6. All right, that is one problem. Okay, so again, I'm going to scroll back up. You can pause this video as well to see the work. Okay, so let's take a look at a second example. All right, so here there are several questions here. The first question is, what is the length of PQ? The next question is, what is the length of RT? And the last question is, what is the length of RS? Okay, so I'm going to guide you into solving this problem. So when you're looking at this diagram, you can tell that PQ is the midsegment here. Okay, so we know how to get the midsegment if we compare PQ with RT. All right, so again, PQ is either a half of RT, okay, or we can say that RT is twice of PQ. The last problem I worked with this definition that AB was half of XZ. The reason why is because it was easier for me to take a half of 34. All right. Here I'm going to use twice of PQ. The reason why is because if I have to take a half of RT, then I'm taking a half of 4x minus 26, and that might take me a longer time, right? So I also want to show you that either way works, right? So RT is twice of whatever PQ is, okay? So twice of PQ is equal to 2x plus 18, and RT is labeled as 4x minus 26. So now we know how to solve this by subtracting 2x from both sides. And we have 2x minus 26 equals 18. Now I'm going to add 26 to both sides. And now I have 2x equals 48. 44. What am I doing? Okay, so that's 44. And now x is equal to 22. Okay. All right. So now x is equal to 22. We can answer some questions. It says, what's the length of PQ? Well, the length of PQ, if x is 22, then that becomes 22 plus 9, which is equal to 31. All right, so PQ is equal to 31. All right, so now I want you to pause this video to check and see if you can understand how to find RT and how to find RS, okay? Okay, so now we know how to find our T because now we can plug in 22, x equals 22, here in 4x minus 26. So RS is equal to 4x minus 26. RS is equal to 4 times 22 minus 26. And 4 times 22 is 88. And 88 minus 26 becomes 62. Okay, so again, RS is equal to 62. I hope you got that. Okay. Now I'm going to show you the work for, sorry, not RS, RT. Okay, so RT. Now we will show you the work for RS. So we know RS, part of RS is 2x minus 13. So if I know that that's the length of PS, and I know that RS is made up of two of these, right, because P is the midpoint, that means that there's two of these 2x minus 13s to find the length of RS. Okay, so RS is equal to twice of 2x minus 13s. All right, so that's 2 times 2 times 22, because that's what x is, minus 13. So that's 2 times 44 minus 13. And then 44 minus 13 is 21. And 21 times 2 is 42. So RS is equal to 42. Okay. And again, that's using the triangle midsegment theorem. Okay, let's go for our last example. So in the two examples, we were talking about the sides. In the next example, we will be talking about angles. So it says, in the diagram below of triangle DEF, G is the midpoint of DE, and then H is the midpoint of EF. So now you can assume that GH is the midsegment, and you can use a midsegment theorem. If angle, so now we're talking about angles, we're not talking about sides. If the measure of angle GHE, so I'm going to highlight GHE, so this corner, that is measured at 10x plus 16. And the measure of DFH, so this corner, is measured at 8x plus 24, then what's the measure of angle GHE? So what's the question mark? What is the measure of this angle? All right. So again, if you look back at the triangle midsegment theorem, we know that these two angles are corresponding angles, and corresponding angles are equal to each other. So that must mean that this angle, 10x plus 16, has to equal this angle 8x plus 24. So if we write that out, this is what it would look like. And now we can solve. So we can solve by subtracting 8x from both sides. And that'll give us 2x plus 16 equals 24. Then we subtract 16 from 24. And that gives us 8. And divide by 2. And that gives us 4. So we know that x is equal to 4. But we only know x is equal to 4. That doesn't answer the question of the measure of GHE. We now have to plug this x back into the equation, x equals 4. So the measure of GHE is equal to 10x plus 16. 10 times 4 plus 16 is equal to 40 plus 16, which is 56 degrees. So we know that GHE is 56 degrees. Well, if they also asked us about DFH, that will also be 56 degrees. Okay, and that is it. Thank you for watching.